So the next problem is 62. This is easier. 2662. So what do we have here? Again, simple circuit. Okay, reasonably simple circuit. Okay, so we have a battery and two capacitors connected like this. Okay, good enough. And what is given? Potential difference across, okay, provided by the battery, delta V. Okay, 60 volts, I will write in a second. Maybe I will write here. So battery delta V is 60 volts. Then, what do we know about these capacitors? The first one, we know its value, and it's 12 microfarads. About the second capacitor, we know the charge stored in the second capacitor, 450 microcoulombs. But we don't know its value. So C2, we don't know. That's what we need to find, actually. So that's the situation. We need to find C2. Okay, let me write here. So find C sub 2. Okay, you know what? Yeah, probably some of you can start solving it or start attempting to solve it. But you know what? Let me write down everything that we can write about this problem. And you remember, again, I already mentioned it several times. So whenever you work with capacitors, you have to work with three quantities, three parameters, C, Q, delta V. Once you know them, you know everything. So now let me write over here everything that we can about all these three quantities, C, Q, delta V. So let me write something like this. So remind you, so we have three parameters. And let me start with charge, for example. So what can we say about charges in these capacitors? It's related to the slide which we discussed before I switched to the whiteboard, right? You remember capacitors connected in series. What do they share? They share exactly the same charge. So Q1, in this case, since these two guys are connected in series, right? So Q1 must be equal to Q2. And I can write, for example, equal to the charge taking from the battery. Okay, you know what? I can probably show that this Q without a subscript, it's a charge, it's a total charge taking from the battery. But here I can write that this is Q1, which is not given, and Q2. And based on the discussions which we made, you remember about those islands, right? Isolated electrons. So we can write that Q1 equals to Q2 equals to Q. So that's what we can write about charges in this problem. Right now, again, it's not, I haven't started solving. I just want to write everything, every piece of physics that we can write. Okay, piece of physics in terms of electronics, right? In terms of this circuitry, what we know about this circuit. So that's what we can write about charge. Now, next one, let's write everything that we can about delta V, potential difference. Okay, that should be simple. Again, it's a slide which we discussed before we started solving problems. Delta V, the total voltage drop across the whole circuit, must be equal to delta V1 plus delta V2. Right? So I can write this. So delta V equals to delta V1 plus delta V2. Okay, so then next, capacitance. So what can we write about capacitance? Actually, not much, except for we can try to use the method, okay, somehow apply method of an equivalent capacitance. And we will see what can be done. So we can use, in this case, these capacitors are connected in series, so we have to use those reciprocals, right? Which I don't like. My least favorite formula. So 1 over C equivalent equals to 1 over C1 plus 1 over C2. Right? Okay, so that's what we can write about these three parameters. And of course, every time you will have to use a formula which connects them all. And that is the definition of capacitance. So every time, it doesn't matter which method, which approach we're going to take, every time we will have to use this formula which connects them all. So let me write underneath of this line. So C equals Q divided by delta V. So pretty much that's all. Nothing else we can write except for to describe it. And of course, you can use some adjective to describe it, but that's from the point of view of physics. That's nothing else can be added. So now let's see methods which can be applied to solve this problem. The first one, of course, every time each method must be based on some expression. In this case, for example, this is not an expression. It's a very important piece of physics, but you cannot use the fact that Q1 equals to Q2 to find capacitance. No, there must be some expression. And in this list of facts, we have only two expressions. For delta V, we have delta V1 plus delta V2. And the second, 1 over C1 plus 1 over C2. As a result, we're going to have two methods to solve this problem. The first one will be based on this expression. The second one will be based on that expression. And every time we will have to use this piece of physics and the formula connecting all these quantities. So the first method will be based on this expression. Okay, let me connect them like this. Formula connecting all these quantities. And of course, important piece of physics about the charge. So that will be method number 1. We will solve it using this method. Second method will be based on this formula for the equivalent capacitance. So based on this, of course, we will have to use again important piece of information about charges and the formula connecting all these quantities. So this will be method number 2. That's it. Nothing else can be done to solve this problem. So now let's solve using this problem using both methods, the first one and the second one. All right. Okay, only now we start solving. Before, I just wrote down everything that we can about the problem in order to identify all possible solutions. Okay, so now number 1 method. So we'll start with the with the expression. So it will be, let me rewrite it. So delta V equals to delta V1 plus delta V2. Okay, so now we need to find eventually capacitance, right? So we need to insert into this equation capacitance somehow. And of course, that can be done using the formula connecting all these quantities. So we need to get delta V, so it will be Q divided by C, right? So it means that I can write it delta V equals to Q1 divided by C1. I'm just using the formula, right? Let me write, so I'm using C equals Q over delta V. And so it will be Q1 over C1 plus Q2 over C2. Okay, so we use this, we use that, right? So you see this, but we still have that important piece of information. And now it's time to use that Q1 equals to Q2, and Q2 is given. So now I can use, okay, let me open my explanation box, that Q1 equals to Q2. So I can rewrite it. So it will be Okay, I can factor out Q2 equals to 1 over C1 plus 1 over C2. Since Q2 now is exactly the same here and there, so I can factor it out. Now, okay, basically, look, this is given, 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 unknown. One equation, one unknown. Now we just need to solve it for C2. This is our unknown, right? So let me put a question mark. So pretty much we're almost done. Now we just need to apply algebra and solve it for C2. So what I'm going to do, I'm going to take this Q2 and bring it to the denominator on this side. So it will be delta V divided by C2, or not Q2, damn it. Q2 equals to 1 over C1 plus 1 over C2. Again, unknown is here, so now let me move this term to the left-hand side. 1 over C2 equals to delta V over Q2 minus 1 over C1. Our unknown is here. So now we just need to flip this, and that's the answer, right? So I can now write that, okay, I will write underneath. So C sub 2 will be equal 1 over that delta V over Q2 minus 1 over C1. And now I need my notes to look at the answer, because yeah, I don't want to plug numbers. You can do it by yourself. 20 microfarads. So that's the first approach, which is based on this expression. So I started from this expression and then used one by one this relationship and that fact. Now the second, which is based somehow on the equivalent capacitance. So let me write again. Let me start with the expression in order to understand what needs to be done. So I will just rewrite this. So it will be 1 over C equivalent equals to 1 over C1 plus 1 over C2. Look, what is not good about this? So every time, okay, most of the time, we use this formula to find C equivalent. Usually these C1 and C2 are given. But here, C2 is not known. It's our final goal. So in this expression, we have two unknowns. We have C2, our final goal, and C equivalent. We don't know C equivalent. So we cannot use this formula to find C equivalent, as I said. Usually that's what we usually do. So it means that in order to find C2, we need to find somehow C equivalent. How can we find C equivalent without using this formula? That's usually the trick of the second method. Okay, in order to see how can we find C equivalent, let me draw an equivalent circuit. Instead of this one, an equivalent circuit. Right. So now let me put some question mark next to that. And once we answer this question, yeah, we should be able to find C2. But first, C equivalent. In order to find C equivalent, let me draw, as I said, an equivalent circuit. Battery and C equivalent. So that is delta V. So an equivalent circuit. And so what do we know about this circuit? Delta V, it's the same, 60 volts, because again, when you introduce an equivalent circuit, the rest of the circuit, in this case battery, must work in exactly the same way. Then we also know that if charge Q is taken from the battery in the real circuit, exactly the same charge Q must be taken from the equivalent, from the circuit, from the battery in the equivalent circuit, right? So, and we know that this Q equals to Q2. So basically we know this charge, which will end up in the equivalent capacitor. Okay, let me write that down. So basically I'm using right now the second fact. Okay, I mean, okay, this one, the first one. All right, so we can write, so Q equals Q2 equals to Q1. So basically we know that. So now look, we know the charge in the equivalent capacitor. We know potential difference across an equivalent capacitor. Can we find the equivalent capacitor, the value of an equivalent capacitor? Yes. Using this formula. You see, again, I used this and now I'm using that, as I promised. So now, using this in equivalent circuit, we can find the value of the equivalent capacitor using electric parameters, charge and the potential difference. Right. Okay, so now as a result, I can find C equivalent basically using that circuit. C equivalent, it's a Q divided by delta V. Of course, you can calculate charge is given because it is equal to Q2. Right. Okay, let me write. So it's a Q2 divided by delta V. Okay, so since in the first method we use Q2 everywhere, right? Okay, so now we found this. We can find C2. Let me show that this C equivalent, of course, now can be shoved in the formula for the equivalent capacitance. And now let me write underneath. So if you plug this in the denominator, of course, delta V will go upstairs and Q2 will be downstairs, right? Okay, so let me show that I will start rewriting that formula over there, plugging this. So it will be delta V over Q2 equals to 1 over C1 plus 1 over C2. And effectively, it's exactly the same what we have here. You see? So we got exactly the same. So now from this point, you just need to do the same manipulations and you will end up with the same answer. Okay, I can even put here asterisk and I can write over here exactly the same as that. Okay, so from here, of course, you can solve it for C2. I will just write down expression immediately, this. So C2 will be equal to 1 divided by delta V divided by Q2 minus 1 over C1. And that will be, of course, exactly the same, 20 microfarads. Of course, in my opinion, the first method is kind of more natural, more smooth, right? Smoother. The second one is kind of a little bit bumpy. Again, it's everything is logical, right? Justifiable, but still, I don't feel natural flow every time. Not every time. It's kind of internal feeling, right? Emotional, my emotions. It's kind of bumpy. Of course, I would just use the method number 1. But every time I'm trying to show the structure of the solutions, right? Or in this case, I want to show everything that we can, emphasizing that there are 3 parameters all the time whenever you work with the capacitor, right? So naturally, we could extract 2 methods, and since we extract both of them, so let's try to use them. But again, still number 1 is, in my opinion, better.